This is Spectra CX, and in this SCA project we have created two models, the DTP4500 platform and the example waveform. First I will show you the platform. The top level diagram shows the DTP4500 platform, which consists of only a single node. If we open the diagram for the node, it will give us the details of what components exist in the platform model. You can see 7 components. In the assembly we have an instance of domain manager, so at runtime when we start up a device manager for this node, it will automatically run the domain manager. We have the standard log service here, and we have the device manager itself. We also have an executable device, which in this case is a standard binary executable device that we ship with our core framework. Since this is a binary that we have pre-built and shipped, so we're not going to be generating code for this. We have an audio port, which implements the functionality needed to interface with the audio output capability of the DTP4500 board. We have a stream of samples that can be sent to the audio port device, and the audio port device is able to use a stream control interface for flow control. I'm able to show you more detail on the audio port device and look at the actual definition of this component. Here is the component interface for the audio port device. And this corresponds to the SCD, so it defines the ports, one of which provides a sample stream interface and the other one which uses a sample stream control interface. It also directly supports the core framework device interface. In the device implementation there's operational code which I'll show you shortly. We have also modeled the binaries itself. We have 2 variants of the binary, one which is built with the release flags and the other built with the debug flags. Currently the model is set up to produce the release version of the binaries. We also have 2 other devices, specifically the Waveform FPGA proxy and the RF control devices. The WF FPGA proxy device provides an interface for the waveform to send and receive data from the Monsoon RF subsystem, and the RF control device which can be used to control the Monsoon transceiver hardware. Again, both release and debug versions of these devices are modeled and can be generated from the tool. The devices currently in the platform for which we actually generate code are the audio port device, the WF FPGA proxy, and the RF CTRL devices, as these also all contain handwritten code. The other devices in the platform model, such as the device manager and domain manager, are models of pre-existing binaries that are part of our core framework. We've included a model of these components but are not going to generate code for them. We're simply going to generate the XML descriptors and make use of them in the platform assembly that we just saw. When we deploy the files onto the target, we will just pick up the pre-existing binaries. The only device currently in the platform for which you actually generate code is the audio port device, as this contains handwritten code. So that is the platform model. The example waveform that I can show you now has a little more content. This is the assembly which corresponds to an SAD file. This contains instances of file input component, which currently uses the file manager to read audio files off of the core framework file system. It then pumps the audio samples to the use sampler component, which upscales the samples from 16 to 48 kHz, before pushing the samples to the mod component, which modulates the samples in the transmit direction and sends them to the Monsoon transceiver via the WFPGA proxy device. In the transmit direction, the WFPGA proxy device pushes I and Q samples from the transceiver to the DMOD components, which will then demodulate the samples and forward them on to the resampler. The resampler will downscale the samples from 48 kHz to 16 kHz and then send the samples to the audio port device in the platform. All 4 of these components are controlled by the assembly controller component, which you can see in the middle. In contrast to the platform model, these components are going to be code generated and will contain some handwritten code. So let's look at the file input component in an example. Again, we have modeled both a debug version and a release version of the binary. If we take a look a little bit further into these models, we can see in the build configuration that this deals with the compiler flags and so on. In the debug version, you can see that we have added the extra flags to allow us to compile in debug mode. This is what these two different implementations are modeling. Again, in the application we are currently set up to use the release binaries.